Hello students, today we are going to study next multiplexer type 4:1 multiplexer. This is the types of multiplexer. Multiplexer is a data selector. 4:1 multiplexer. For 4:1 multiplexer, first this is the combinational circuit. That 4:1 multiplexer 4:1, that multiplexer many input one output. So that type 4:1, there are the four inputs D0, D1, D2, D3. There are the three inputs. These are the data inputs. These are the data inputs. Next, there are the two select lines are required and one output. This data selector, that relation n is equal to 2 raised to m, where m is equal to number of select lines, where n is equal to data input lines. That number of data lines depends on a select line. So select lines are 2 raised to 2 raised to 2. So number of input lines are 4. Number of input lines are 4. Or number of input lines are 4. When that number of input lines 4, that select lines are 2, then number of lines are 4. So select lines are required for 4:1 multiplexer 2. Number of input lines are 2. So that relation n is equal to 2 raised to m. This is the select input. This is the output. This is a select input. And from this truth table, that enable input is not taken here. That is, from this truth table diagram, we design the truth table. There are the four input lines, select inputs. This is the truth table, select inputs and output. That output y. Select inputs are, this is the truth table, R2, S1 and S0. Then there are the four combinations, that 0 0, 0 1, 1 0, 1 1, 1 1. So when S is equal to 0, S1 is equal to 0, data input is select D0. So this D0 is route output as a D0. So output is a D0. When S0 and S1 are 0 1, 0 1 means 1. So input line is selecting as a D1. So D1 output is routed as a Y output. So output Y is equal to D1. When S1 and S0 are 1 0, 1 0 means in a 2-bit that number is represent 2. So D2 input is select. So D2 input is select, that D2 output is routed as a Y output. So output as a D2. When S1 and S0 select inputs are 1 1, that 1 1 in a 3-bit represent 2-bit as represent 3 number. So D3 input line is selecting. So output Y is routed as a D3. Output Y as a D3. So this is the truth table for multiplexer 4:1 multiplex. And for multiplexer, there is a not required the K-map simplification. From truth table we directly write the equation. So y is equal to equation, this S1 S0 inputs and output, this is a D0. From this we consider as a S1 bar S0. Here is a 0 0, that 0 is indicating as a bar in an expression. So this is a D0. For this term, that is S1 bar S0 D1. Next this S1 S0, S0 is 0, so S0 bar D2. Next this is S1 S0 and D3. This is the expression, and from this expression we realize the diagram. So there are the bar in S1 and S0 bar. So for S1 input we connect as a NOT gate, and this is a S1 bar. And for S0 input we connect the NOT gate. So this output as for NOT gate is a S0 bar. Then this term, for this term, this term, we require the AND gate. 4 AND gates are required as the ANDing terms. So we require the 4 AND gates. And from this equation we realize the diagram. S1 S0 bar, S1 bar S0 bar, and this is the D0. So output of that AND gate S1 S0 bar D0. Next term S1 bar S0. So for S0 we connect and input as a D1 given. So output of that NAND gate S1 bar S0 D1. Next S1 S0 bar and D2. So output S1 S0 bar D2. Next this AND gate S1 S0 D3 input, and for all term there is a addition, so we take here one OR gate connected. This is the Y output total for this equation. This is the multiplexer type 4:1 multiplexer. Next is multiplexer type 8:1 multiplexer. 8:1 multiplexer. For this multiplexer, how many number of input lines required, how many output line required, how many select input line required, first we think, and then we design that block diagram for 8:1. 8:1 mean how many input lines? There are D0, D1, D2 up to D7. There are 8 data inputs are required. 8 data inputs are required, and then one output. 8:1, main input, one output, but 8:1 multiplexer, 8 input, one output. From D0 to D7 there are 8 input line. One enable, that is E is connected. In the last multiplexer we not take that enable, but in this we take the enable or strobe. This is the enable or strobe. This is used for cascading purpose. And that relation n is equal to 2 raised to m, where n is equal to 8. Then how many number of select lines are required? 2 raised to 3 is equal to 8. So number of input lines are select input lines are required for 8:1 are 3, S0, S1 and S2. These are the select inputs. And from this block diagram we design the truth table. This is the enable, this is the active low, but not here I am taking the active low, directly enable input is taken. Enable, this is the E, select inputs, input lines, so S2, S1 and S0, truth table. And next output as a Y. So enable is a active low. This is a enable is a 0. Here is not active low. If active low, then this is a multiplexer is working. But here I am taking only E. So for E0, not input here applying. So S1, S2 select the as a input as a don't care. S1, S2, S0, S1, S2 as a don't care. So output is a 0. When enable is 1, mux is a enable. So S2, S0, S1, S2 are 0, 0, 0, 0, 0, 0 are select input. That input is select as a D0 input is select. So output is routed as a D0. That multiplexer select one input line, n data routes, n number of data inputs routes to the output, and to select n inputs we need m select lines. We require m select lines. So from this select line, which select line data is select, from that input is selected. So output as a routed as a Y as a D0. Next enable is 1, S2, S1, S0 are 0, 0. So output input as a D1 selected. So output as a routed as a D1. Next enable is 1, 0, 1, 0. This 0, 1, 0 means 2. So output is select line data having 0, 1, 0. So input is selected as a D2. So D2 output as a routed as a Y output. Next, when enable is 1, 0, 1, 1. 0, 1, 1 means D3 input is selecting. For select line data is 0, 1, 1. So input line D3 is selecting. This D3 is Y output as a routed. And from D up to this we D0 to D7, that is the 8 input lines. There are the 1, 0, 0. This 1, 0, 0 input as a D4 select, output as a D4. Next 1, 0, 1. 1, 0, 1 as a select input. So D5 input is select. So output as a D5. Next enable is 1, 1, 1, 0. Input as a D6 is selecting. So output as a routed as a D6. Next 1, enable input as a select input as a 1 1. So input line D7 is selecting D input is select, so output as a routed as a D7. This is the truth table for 8 as to 1 multiplexer. And from this truth table we design the equation. So first, y is equal to E, first term S0 bar, S1 bar, S2 bar, S0, S1 bar, S2 bar, S1 bar, S0, D0 for this input. Next, this D1, S2 bar, S1 bar, S0, D1. Next, S0, S2 bar, S1, S0 bar, D2. Next, S2 bar, S1, S0, D3. Next, S1, S2, S1 bar, S0 bar, D4. Next, this S2, next for this D5, S2 bar, S2, S1 bar, S0, D5. Next, D6, S2, S1, S0 bar, D6. Next, this is S2, S1, S0, D7. This is the equation from the truth table, and from this equation we design the diagram. So that inputs as a S2, we connect the S2 bar as output, NOT gate. Next, S1, for S1 we connect the NOT gate, so as a S1 bar. Next, here S0, for S0 we connect the NOT gate, so output as a S0 bar. This is the as a diagram, and there are the 8 AND gates are required. There are the 8 terms, 3, 4, 5, 6, 7, 1, enable input as a common for all. This is E, S2 bar, S1 bar, this is S0. Next, enable and a D0 and D0. These all terms are connected to OR gate. This is the diagram for 8 OR gate we connect here. For OR gate we connect as these all outputs of AND gate, and this is a total expression for Y output. This next term S2 bar, S1 bar, S0, enable D1 as a D1. For all gates from this terms take, and that all gates are for inputs this connecting. S2 bar, next S1, next S0 bar, and next for enable, and next is D2. Next term S2 bar, S1, and this is S0, enable is connecting, and input as here D3. Next D4 as a S2, S1 bar, S0 bar, and enable and D4 input. Next term S2, S1 bar, next this is S0, enable is connect, and this is a D5. Next term as a D6, as a S2, S1, next S0 bar, enable is connecting, and here is a D6. And last term as a S2, S1, next S0, and enable, and as a input as a D7. and these all terms are here outputs. This is term S2 bar, S1 bar, S0, D0. These are the, for every AND gate, these are the all terms for, and that all and terms we there is a plus sign ORing, so we connect one common OR gate. This is the multiplexer 8:1 multiplexer. From these